script that died. So what I did last time when I was doing the sort of trial session was sit around with folks and we built a little library for playing around with commutative applicative functors. So what the heck is a commutative applicative functor? So glad you asked. We didn't actually have any ability to describe them before. We'll just start with commutative semigroups. And so the first thing the library had to have in order to talk about commutative, what applicatives can commute, was the notion of what monoids and semigroups can commute. So I went through base and just started capturing everything that should be commutative. And yeah, let's just give it. If lambda bot works, great. If not, it fails. So void is commutative. Any and all are commutative because they're commutative on input. They're a full-fledged semilattice. Min and max also form that like join semilattice. Sets form a semilattice as well. If the semigroup that you're lifting over option or maybe, which now that maybe has the fancy new instance in 8.4, this option thing can finally die. Those are going to be commutative. So for the folks who are less mathematically inclined, commutativity is just that A plus B equals B plus A, that it doesn't matter the order in which you append these two elements together or something. And so I really wish we had some good way to break down how much of the audience is completely new to Haskell and how much are Haskell regulars who just want to see me talk. So I don't have a good way to run a live poll like that or anything. I'll have to figure something out like that for next time. So yeah, so the code right now, as Vivev just mentioned in chat, is GitHub ecommit abelian. If you scroll down in the how do you do that? You get to. I can't pronounce your name. I'm sorry. You get. Is there a fancy tool to do a straw poll, or you're just meaning just dump it out into the chat? All right, there's a link. I'll dump it into the chat. Try that. We can let that accumulate in the corner here. That'll give me some idea who the heck I'm talking to. Akrish, you don't need to know category theory. Any category theory you need, I'll try and introduce as we go. I admit that some of the stuff that I'll be doing here is going to be me working on stuff that I want to work on, and so I admit there will be times when I will just dive deep. Well, we're actually getting it's a pretty good even ratio. I was expecting it to be about 50-50, so it's a little bit more old hand than new to Haskell, but then again, I did a lot more kind of sending things around to folks on Twitter and on Reddit and whatnot, so that skews things a bit. So hopefully over time we'll get a slightly more organic growth on the new to Haskell side. So for those who are completely new to Haskell, we have a class named Semigroup, which has, and I'm going to assume you have some familiarity with the notion of a type class and whatnot. If not, then some of this might go over your head, and I apologize. But the idea here is that this operation, which can be anything you want, as long as it is associative, that should be that M so what things fall into that? Addition, multiplication, min, max, set unions, and an or, etc. There's lots of things that happen to satisfy this associativity condition. And here what we're trying to do is say that M append N is N append M. And the answer is just me trying to make this into a legal Haskell comment so that when it gets formatted, it'll get formatted pretty. Okay, so that's basically where we're at. We just have, yeah, set intersections also form a semigroup. And then if you want to go a little bit further, then we can go on to say class semigroup M gives us monoid M is a subclass of semigroup where we have a unit, which we in Haskell call mempty for some historical reason. Not the best name for a unit, but it's what we have. And there you start getting laws that M append mempty is M is mempty. M append M. And examples for things that are associative but not commutative, as Karamian mentioned, there's matrix multiplication. There's a lot of things like you can make a semigroup that just computes, that just gives back the first result. So you can say data for new type first, A is first A, and then instance semigroup first A, where first A appended with anything is first A. And we can just do that. And this is an example of a thing that doesn't have a unit, and it doesn't have commutativity. Okay. So currently I'm building on GHC 8.4, which is kind of the bleeding edge. And in that version, this line of code is true. This is actually the way monoid is defined in base in 8.4. And so I started this little library on 8.4. And so one of the things that we might do is try and backport this to older versions of Haskell. Okay, so we have a pile of laws. We have the thing that we're trying to express by saying that something is a commutative semigroup. And then I have a bunch of random instances of commutative semigroups. And these are not necessarily the best teaching examples because they are everything that is in base. That was the thing that we worked through during that sort of first prototype session. And yes, string concatenation is associative. But it's not commutative. If I tried to do this in the other order, you're going to get a very different answer. Okay. And I'll kill the live rebuilding that we have going over here. So here's a pile of commutative semigroups. There are a bunch of things that exist in data.monoid for folks who already are more... I'm going to switch a little bit more towards the folks who are a little more familiar with Haskell. The yes, option is currently sitting in there. It's buried in data.semigroup. We can't purge the Haskell world of that blight yet. The 3 release policy is going to make us hold on to it for at least three revisions past 8.4. So 8.4, 8.6, 8.8. You'll have to wait for 8.8 at least before we can start killing option. Lambda-bot still being complainy. All right. Struff hole's in. It's about 60-40. Okay. That's going to be a really handy little site. I'm going to bookmark that thing. All right. So what do we have? Function spaces. If something is a commutative semigroup, a function that returns that thing is a commutative semigroup. I'm going to blow this up because pairs of commutative semigroups form a commutative semigroup, etc. The proxy is a semigroup. The only value in proxy is proxy. If you tag a commutative semigroup, you get a commutative semigroup. And then basically, if you're a commutative semigroup and you're a monoid, you have everything you need to be a commutative monoid. So I just use the sort of class instance hack in order to make this class up without having to make people write instances. All right, so we now have the notion of a commutative semigroup and a commutative monoid. And then that really wasn't the thing that I wanted to build this out of, or built this about, but I needed those in order to start expressing the idea of a commutative applicative functor. And so here's where I admit we're going to go way deep for the newbies. So in Haskell, we have a class named Applicative, which is a subclass of Functor, which means we need to know what a functor is. So I apologize here. This is where we're going to start washing past where, if you're not familiar with Haskell, where you'll be able to keep up. So here we have two operators. And pure. And the idea is that applicative is also about associativity. There's a nice little associativity law that we can talk about for applicative functors. And this is the same thing as monoid, kind of one level up. New type, we wouldn't have to write your new type hash map with a commutative monoid. Well, I don't know. So maps are a bit of a mess, mainly because there's a proposal in the works to make things, type in something with flip. Typo, did I typo something up here? Oh no, this one here this is an extra operator that is in control applicative. So once that's done, you can compare the type of that with the type of that, and they should be the same. So I was being excessively clever. Okay, so here we have this notion of an applicative functor. I'm making this notion of a commutative applicative functor. And here, if you have applicatives composed through the functor composition, so if you go to compose two commutative applicative functors, the result is commutative. Writer and lazy writer, these are the reasons why we needed all the commutative monoid stuff, are commutative if the monoid is commutative. The anonymous writer that we have for pair with some value. I suppose I should be consistent. Function spaces are commutative. So this is sort of one of the canonical examples, and it's going to be the thing that we're going to use to motivate lots of the other things being commutative. Did I? Oh yeah. To be consistent here, I'll just go down to there. It doesn't in general. That is the law of this class. I'm sorry. King of the Homeless mentioned that star equals flip star star. Is not a law normally, and that's what we're gaining by making this commutative class. Is we're gaining the ability to start shuffling applicative operations past each other. Let me shuffle a couple of things off the screen here. Come on, there we go. Just want to be able to see what's going on. Maximize that and shrink the border between those two things. All right, now I can at least see what's going on since I lost all of my setup. And sorry, Jenny, where a large part of this is me trying to set up to live code what I am actively working on. So I'll confess that a fair bit of this is going to wash past people who are completely new to Haskell. A lot of this my main goal here was to start trying to give some folks some insight into the day-to-day existence of somebody who is writing Haskell at a fairly high level. Oh, so as for hash map and proposals. So there's been a proposal to change the instance of monoid for map, at least, in the containers package, not the hash map yet. And so I think in 8, with the version that's going to go out next for containers, I think the idea is to rip off the Band-Aid and finally make the version of map that depends on the argument being a semigroup in order to merge them together. So you'll be able to finally have maps that mash together their contents rather than just take the first one with the union style functionality that you get now. Okay, so we have, let's see if I lost my mouse here. We have reader is commutative. As an applicative goes, it doesn't matter if you look at these things for reader, you're going to get what is app there. It's going to be f of, let's just write this out, f of a arrow b, f of a goes to f of b, and f here is function from e, so this is going to be e arrow b, this is going to be e arrow a. And here, this is under the hood, f, g, e equal, or this is, well, what do we do? F of e applied to g of e. Here, there's nothing that actually stops us from evaluating this in the opposite order. Like if I were to, there's no inherent order to the effects of reading from the environment E. And yes, this is a funny way to spell S. So in my linear package, there's a bunch of small dimensional or low dimensional vector spaces, info v3. So here's like a 3-dimensional vector. It takes 3 A's, and you can view this as like it was a function space from a thing with 3 things. Similarly, if you look at data.complex, complex is a data type that holds 2 A's. And so you can view this as isomorphic to a function space from bool. And how could you do that? You could say, well, if we define something like tabulate, which is going to take a function from whatever the representation of f is to a, and gives me an f of a, and we define index, which takes an f of a and gives me a function space from the representation of f to a, then what we're going to get is that we want these two functions to be inverses. We want tabulate.index equals id, and we want index.tabulate equals id. So here for complex, if we pick f to be complex, we want the representation to be bool. And so I want to say that complex should be every complex a, where a could be normally double or something like that, is in one-to-one correspondence with the function space from bool to a. By witnessing that with this tabulate and index. So how would we write those? We would say something like tabulate, given a function, is going to give back a complex number, which is going to be a x, and then this colon plus thing. So let's f of false plus f of true, and then tabulate f, that's tabulate's done. But if we want to index into something like this, we have a plus nothing, evaluated at false is a, index evaluated at true is, let's call this b. So we can use the function space to interrogate this for like the real and imaginary parts. Okay, so this is the idea of a representable functor, and I have this separate packaged up in a separate package called adjunctions. But since they're representable, they're isomorphic. F of A is isomorphic to a function space from whatever the representation of F is. So all of the vector space types that are lying around in my linear package, the 4-dimensional vector space, the 3-dimensional 2, 1, this thing for Plücker coordinates, more complicated one for n-dimensional things, complex numbers, quaternions, etc. All of those are special cases of this. Reading from an environment doesn't cost you commutativity case. Identity, you can view this as a one-dimensional vector space, so that didn't do anything. Applying the identity monad transformer to a commutative applicative is also a commutative applicative. Functor products of two commutative things are commutative, but note functor sums are missing. So there's going to be things that are missing from this list. Maybe T is here, but either T is not. Reverse and backwards are here. Const tagged proxy. Kleisely's missing an applicative instance in base. It's really reader in disguise with flipped arguments. Notice zip list is commutative, even though if you looked at the monoid for zip list, it's probably doing... I don't know what the monoid for zip list does, if it has one. We don't have one. Okay. So this is an instance of commutative, but not a commutative semigroup, etc. Yeah, so Kieran, that rep thing is, it's in the adjunctions package. Yes, the composition of two commutative applicatives is applicative, and that's up here. And that actually is how we inspire a lot of these instances down below. So if you look at this one, this is the same kind of thing. But if you look at a lot of the lifting of commutative applicatives over like certain comonads and stuff that I have buried down here, those also turn out to be the case. Okay. So semigroup first, semigroup last. Note that as an applicative functor, first and last are commutative, even though first and last are not commutative monoids, because they're basically the identity functor in disguise, but they have a different instance for semigroup. So a few releases back, we started dumping in all the. There's only one possible way to build this instances into base, and so we went and added these. Part of the stream on Saturday? No, I guess it was Friday night. Late Friday turned into Saturday. Was to go through and file GHC track tickets for a lot of these missing instances. So I went through and log in, view tickets. I don't even remember how to query these things. All tickets by milestone. Oh wait, active tickets mine first. That's a good one. So we filed like 3 GHC track tickets the other day. Sort them by ticket number, maybe? The other way around. And then one of them was closed out as a duplicate with the other two. That we were missing various instances for data.monoid alt, because alt was added in base 4.8, but it wasn't, didn't have all the instances that it could. It was missing foldable and traversable and stuff. And then if we looked at down, it was missing almost everything because it was buried in data.ord and nobody looked at it. So it was missing instances for just a ton of things. So we wound up filing issues for all of those. Hopefully those will get merged upstream into GHC, and then downstream in something like semigroupoids, I went and added a couple of orphans and stuff like that in order to enable us to get everything that we need here. So as much as I hate orphan instances, I sucked it up and wrote 2 of them. But then fixing those led to fixing a bunch of missing instances in free and in semigroupoids, and yeah, so we spent probably 3 hours just randomly writing instances that were missing and then fighting with safe Haskell. Yeah, and so we were missing the applicative instance for commutative, or for K1, and these are things that are buried in GHC generics. So this stuff is all about, let me start grouping these. GHC generics. This stuff is in the Commutativity package. This stuff is in data.semigroup. What do we have up here? This one is also in monoid. So all of you belong in monoid. You're in semigroup. These things live in data.monoid. These things lived in the tag package, or technically proxies moved into base. Code Kleisli has been buried in the Commutativity package. Control applicative. Control arrow. What are we missing? These things are in, this is in control applicative as well. Const, reverse and backwards, maybe T. Functor product used to be in transformers, but now it's in base. Identity, let's just call these things all transformers. Not that these things are actually being used as static comments, so I don't really need to mangle them like that. These are all things for linear. Reader T belongs down in wherever we did transformers. Just trying to get these things grouped up a little bit more sensibly. So the reader and writer case are here. This guy belongs with the transformers instances. But notice that we're missing a bunch of things. State is not commutative. Either T is not going to be commutative in general. And we're seeing a sort of recurring pattern along those lines. Validation, which is like buried in, I think, the either package, with a commutative monoid as the thing you're validating with, or commutative semigroup as a thing you're validating with, would actually pass. All right, so that's it. We're starting to get some instances that are slightly more interesting. And now it's somewhat telling that validation, which is isomorphic to either, is commutative, but either is not. It's because either takes the first error, whereas validation gathers up the errors with a monoid, or with a semigroup. But as a result of it gathering up the errors, it can't be a monad. So we get all sorts of knock-on consequences here. All right, so we now have sort of a rogues gallery of commutative applicative functors. And one of the sort of major motivation for this that I had was I was walking like a couple of days ago and I realized that we don't actually have anything that could use like a free monad to model something like Haskell very well. So Haskell is, for those who aren't part of the sort of, Haskell Illuminati around here, is a monad that was written for fighting spam at Facebook. It's used internally inside of all of the stuff that Simon Marlowe has for doing spam fighting there. So what happened was they had a little domain-specific language called FXL, which was what they were using to write this thing they have called Sigma, which is their internal spam detection tool. When you feed it a post, it gives back either a quick answer of this is spam or not, or maybe we need to chew on it a little longer, and then they can go into a slower path and chew on it. All of that stuff is built around this ability to query all of their data sources. Haskell is a monad, but it very carefully tries to abuse as much applicative information as it can to gather all the queries that it wants. And so Haskell is a legal monad if you're willing to assume that the queries aren't going to change the state of the world and that you would get the same answer up to the set of semantics you want out of asking the questions in different orders or batching up versus not batching them up. There's some chatter in the chat room here about is Haskell a monad or applicative. It's been kind of a bit of a contentious issue because it does optimizations that on the nose you're not allowed to assume, but that are safe enough for their particular domain. Whether Haskell itself should exist in its form as a library where it's currently written like a monad transformer. Here, I think one of the ideas is to argue that really Haskell should be built as sort of a commutative monad transformer. Ariakonem, Haskell was the example that I had in mind. Sorry. Commutative for Uneta, co-Uneta day, etc. So one of the things that I do need to do today, we don't have commutativity written up for contravariant functors. So that might be a good exercise to just kind of keep pushing this forward before we dive into what the commutative free monad, etc. looks like. But commutative free Uneta, co-Uneta day. Oh yeah, the missing instances. Definitely. So we should be able to do them for Uneta, etc. We don't currently have a... Let me shrink this a little bit and pop open GHCID. So we can... So GHCID, if you're not familiar with it, is sort of a minimal like pseudo IDE. It's enough to get the repeated build spam out of your workflow. It's written by Neil Mitchell. It's a nice little install. I do recommend. Do I need to explain what a contravariant functor? Yeah, okay, I should explain that. So let's do... First, we have to get the Uneta things, and we also need to get the contravariant functor stuff in here. So let's first incur the dependency, and then I'll try and motivate it. Contravariant. I don't actually know the current version of the contravariant, even though I read it. Uh, 1.4. So, by the way, when I incur dependencies on my own packages, I use the first digit of the package version number, which is a little bit wider than what the PVP allows, but I'm doing it on my own package, so I know when I'm going to break myself. And yes, we'll... Ariakonem was wondering whether or not Haskell was motivated. I wanted to include Haskell as an example because it was a good general audience example, whereas all of the random stochastic ray tracing stuff is a little more esoteric. All right, so we have this now. We now have a dependency on contravariant, so now we can start talking about what control commutative. I guess this should be data functor contravariant commutative. Trying to figure out where this should live. And then I'll explain what contravariant is. Okay, so I'm going to whiz past a bunch of classes here. I'll give the basic idea of what a contravariant functor is, and then I'll talk about what a divisible and what divisible and decidable are. And and I'll sketch that they have laws. There is a talk that I have given before. Let me give the link. Discrimination is wrong. Improving group productivity. And this was not a... It sounds really social justice-y, but it's not. Here is actually the version I gave of this at Zurahack, or Google Tech Talk. Yeah. So here I'll paste this into the chat. It might actually be in the history, but or in the video list that is linked in the channel feed. But that talk actually goes and gives a very deep dive into what it means for what applicative really means, and what the dual form of what the sort of, not the dual form of applicative, but what applicatives from a contravariant or built around contravariant functors look like. So that's where divisible and decidable come from. They're not quite co-applicative, and they're not quite contra-applicative. They are applicatives built from contravariant functors. So what is contravariant? It's contravariant F looks like this. So when we defined functor before, we had fmap. And this said, if you can give me a function from A to B, I can turn an F full of A's into an F full of B's. Contravariant has this other operation, which says if you can turn an A into a B, I can turn an F of B's into an F of A's. And this seems paradoxical. I don't have an F full of B's or an F full of A's. I have a thing that acts kind of like... yes, Kieran, I did actually finish the problem at the end of that talk. I solved about a month later. So there's a... the code in the discrimination package on Hackage uses a library I have for quote-unquote lazy promises to resolve the question that I said, hey, look, there should be some kind of lazy promise-like thing, and then eventually I figured it out. So the discrimination library, for those who aren't familiar with it, is sort of a library for sorting an unnaturally fast, at least asymptotic time in Haskell. And if you're curious about more of that, then that talk that I linked goes into more detail. The promises library that goes with it is actually something that's probably worth talking about in another session at some point, because it's an interesting little library that nobody really knows about, because I haven't done a great deal of evangelism about it. Okay, so back here. So we had functor. If you have a F full of A's, you can think of a functor like a container in that regard. It doesn't have to be a container that holds a finite number of these things. It can be a function space. It can be all sorts of things. But contravariance is funny, because there is only one source of contravariance in Haskell, or in most programming languages, which is that functions are contravariant in their first argument. So F is usually going to be something like a predicate on A's. And this is going to be like A to bool. It's a function from A to bool. Okay, so here, if you can give me a way to map, I don't know, ints into, or doubles into ints, and you have a predicate that knows how to take you have a predicate on int, I can give you a predicate on doubles. And so we can just define this by writing up the instance of contravariant for predicate, which is that if you contramap F over a predicate G, you can just sort of precompose F. So this is our first example of a contravariant functor. There's nothing that says that you only have one A, or that A only occurs as a function space. Like if I had a list of these things or something here, this would also be a contravariant functor. A good example of something that's a little bit bigger is something like we have the notion of like an equivalence class. Get equivalence. Are these two things in the same equivalence? And then you'd want to have some extra conditions that say that this relationship is symmetric, it's transitive. Is there a relationship to profunctors? So profunctors are contravariant in their first argument and covariant in their second argument. So contravariant is sort of a building block to get there. Okay, so now we can build a couple of instances of contravariant. Contravariant equivalence. You give me an A and a B, and I will call G on f of A and f of B. So if you can sort of precompose any function you want with any equivalence class. So if you started with a legal equivalence, like notion of equivalence classes, you now have a new notion of equivalence classes on this broader thing that you can map in. Is there no other possible way to get contravariant except for functions? The only other way to get contravariance is to be completely independent of the parameter. Data proxy, A is proxy. This has no use of the argument. Done. Okay, so yes, the only way to get it is to go backwards through like a function argument. And that is sort of the only source of contravariance that we have in Haskell. Or in really almost every other programming language that you can think of. So data, predicate, contravariant. We've got a pile of these instances now. So now the idea of a contravariant applicative functor. So when I first thought about applicatives, I thought, well, maybe there could be like a contra-applicative. And then I started trying to figure out what that would mean. Like f of A arrow B. I totally just got muddled in this thing, trying to figure out like how to, like if f was a contravariant functor, how would you mash this together, etc. It's only really through using the lens of something called day convolution, which I go into detail in that talk that I linked. And I suppose I should just keep the link to the talk up here in the session. And it's there it is. Is there a good place to pin this? There, it's at least visible for now. I'll just leave it there. So if you really care about like where contravariance comes from, there's that. I think there's probably an article on commutative.com or something as well. Okay, so how do we build this thing? So I have a class called divisible and decidable because the idea was and rather than call, because it's not really contra applicative, etc. It's its own thing. Both of them are monoids of day convolution, which is a messy thing. So I named this thing divisible and decidable to try and figure out like how to call it. So divisible f gives me a couple of operations, and I called them to try and come up with pithy names: divide and conquer. Okay, so if you can split an A into a B and a C, and you can handle B's and you can handle C's, because if you think about it, the notion of contravariant here was like handles. Here, if you can turn an A into a B and you can handle B's, then you can handle A's. As a way to like when we talked about functor before, we said if you can turn an A into a B, you had a container full of A's. You can get a container full of B's. The contravariant is more like can handle, and this is again kind of wishy-washy, but that's the idea. So here, what I'm saying is if I could split A apart into like two parts, the B part and the C part, and I can handle those things individually, maybe there's a way to merge the handlers, or the ability to consume. That's pretty good. If you can consume B's and you can consume C's, you can consume A's. So I use divide and conquer. And this says you can handle everything. There's a default way to handle. And then these have a nice set of laws that work with them. And I'm not going to try and derive them live in the stream. As a matter of fact, there was a typo in the version of the laws that is on in the contravariant package. So data functor contravariant has just the contra map, which I mentioned. And it also has, where did I scrolled past it? The divisible and decidable classes. So divisible is contravariant applicative. And it has divide and conquer. So if you can split A into B and C, and you can handle B's, you can handle C's, you can handle A's. If you can always handle A by doing nothing with it. And yeah, commutative instances have no body, so all they are laws. They're just telling you a law. And then up here, I think I gave a law, but I think I typoed it. I don't know where the law is stated for divisible and decidable. Are they written with the... there was an issue to fix it just the other day. But if we go up here and we like define like as a convenience function, we just say that delta is I'll take an A and give you a pair of A and A. So we could just define this because then it'll be easier to see the associativity condition. So delta A is just the pair of A and A. It's like the function signature, just replace this with an equals. And now we can start talking about what does divide delta look like. Divide by delta, or divide using the delta function is going to take an f of A and an f of A and give you an f of A. So if you can split A into a part that is still, if you can handle A's and you can handle A's, then you can handle A's. This is not as informative. But now divide delta, conquer M equals divide delta M conquer. This is what we want. We want conquer to be sort of like, what is the default like predicate or equivalence or something like that? Well, and then a way to merge, or to use two of them to answer similar questions. So we can say, well, divisible for, what did we have? We started with predicate. So conquer is going to be the predicate that just kind of says, yeah, everything passes your test. And then what is the thing that's going to be the unit for? It's going to be and. Divide using F. You're going to get a predicate G here. So we're going to build a predicate. It's going to say, well, give me an A. I'm going to case G of A of. This is going to split it into two parts, B and C. And then, we got a predicate. What did I do? I screwed this up. Predicate case F of A. Predicate G, predicate H. So we want to feed G the B part, and then we want to AND that with the H of the C part. So this would be how we would define divisible for predicate, and then we can carefully show that true here is going to act as a unit for this monoid that we have underlying this. So we can build divisible for predicate. We can be careful, and we can build divisible for equivalence. Divisible equivalence, where conquer is going to be the trivial equivalence class that mashes everything into the same equivalence class. It says they're all in the same one. Divide F equivalence G equivalence H is the equivalence that takes an A and a B and says, well, case F of A of B and C, in case G of B of, or I should call this something else, A prime, A double prime, whatever, GB of B prime, B double prime. Then what are we going to do here? We're going to say, well, compute, no, this is F of B, sorry. G of A, B, A prime, B prime, and end that with h of a double prime b double prime. And yes, I manually indent. In some sense, this development environment is very minimal. It's partially because I recently had to rebuild my machines. I had 3 machines all get fried by one bad Apple power supply in rapid succession. And so I've been in kind of a recovery mode. So this is a very minimal environment. And yes, I made a very wrong editor choice in my... It wasn't my teens. I was 8 or 9. So, when I first used some flavor of VI. So far, so good. So, or and false would work just fine as a thing, but it's not a very good predicate. It was really the... And what I meant by that is it wouldn't generalize nicely to the equivalence class thing, I think. So here what we have is you give me 2 ways to break things up into equivalence classes, and you're a member of the new way to build things into equivalence classes if you're a member of both of these things. And I want that transitivity condition. King of the Homeless, I could do many things like that, but then when I moved to somebody else's machine, I would look like an idiot as I flailed around outside of my keystrokes. So if we look at my vimrc, it's pretty minimal right now. And I added syntax on because somebody was complaining. So divide equivalence, divisible equivalence. I think these are pretty obvious. Okay, so now that we have this notion of divisible and decidable, which are all packaged up nicely for me, what I want to do is say when divide is commutative. If I can split A into B and C, does it matter the order in which I handled B and C? In both of these cases so far, and is inherently commutative. So we didn't need to do anything in order to have these things pass the notion of whatever a commutative divisible functor will be. So both of these things pass the test. Do everything pass the test? Well, the answer is no. And we can see that by going off to build a new type for, like, what was it? I gave it a name over here. Divisible comparison. A comparison on A's is going to take 2 A's. And give you back an ordering. This is eq, less than, greater than. And we can say contravariant comparison. Well, we can just steal the code for equivalence, because and then when we get around to defining divisible for it, it's a bit messier. This is the comparison that first says that everything is equal. And then divide. Divide comparison GH is going to do something where we first say, well, we're building a comparison. It's taking an A and a B, and we're going to use f of A to build an A prime, an A double prime. So we're seeing a very simple pattern here for this one. And then here what we do is orderings have a semigroup. If the first thing is equal to the second to something, and then the second part of a pair is less than, then it fails. But if we look at this, like less than, like this looked like it worked, but if we had less than, greater than, and greater than, less than, we get different answers. So this is not commutative, this particular semigroup. So comparison is an example of something that is divisible, but not a commutative divisible functor. So we have predicate, equivalence, comparison. There's a bunch of stuff for state vars and a whole pile of things that have instances for kind of mediocre technical reasons. Another example would be something like if you look at the you could actually build a meaningful contravariant functor out of A goes to unit for things that do various forms of like seeking on their arguments. That's an example of like how would you build all of the eval or whatever the heck the strict stuff is that we have. Why is stuff so simple into why stuff such things as so simple into an equivalence or comparison new type? What does it enable? So in the discrimination package, which I was not planning on going into today, I have all sorts of examples of contravariant functors that are not trivial. So there's this notion of a sorting functor, which A here only occurs in negative position. So it's on the left-hand side of an arrow, but then it's under a list. Okay, so this is an example of a contravariant functor that has more structure to it. What does it enable? Well, figuring out how to write some of these instances is not trivial, and they then allow me to go through and build a bunch of stuff for sorting almost everything interesting in Haskell in quote-unquote linear time in a way that I'm not going to bother to fully elaborate in this forum. The grouping contravariant applicative is even worse. So this thing has an A, and you can show that it's buried on the left-hand side of a function arrow, but it's under an M and under all of this garbage. So we can reuse it much like we use a monad or another kind of abstraction in Haskell. So I build this notion of group, and then its instance of grouping is all based on this crazy stuff about building new mutable variables and stuff under the hood. And you shouldn't want to have to re-implement this every time you do things. It's basically like building up any sort of reusable abstraction. So I'm using predicate and equivalence and comparison as starting points because they're approachable, not because they're the limit of what we care about and that happens to be contravariant. Okay, so we now have this notion of divisible, comparison, etc. What do we need? I can just import this stuff, data functor contravariant. Commutative divisible. That needs a better name. Contramutative? I don't know. Anybody have a suggestion for a name? Divide F, FB, FC. Yeah, you could write it that way. FC, first of A, FB. You have to be a little bit more careful because there's a bunch of new type noise as well, Chris. Commutative divisible is on the nose. Contramutative is cute. I don't really care. I'm trying to make up a name as I go here. I'm going to work with contramutative right now just because it's shorter to type. And then someone can come up with a better name as we work. I'll let people... is there a way to make an open straw poll on that straw poll site? Anybody else have suggestions? There, good enough. I'm going to consider the poll non-binding myself. I'm going to click that one just because, actually, that one or that one, I don't really care. I'll let this run off to the side. Oh man, commutative divisible. Nobody likes puns and qualified imports. Too many M's in the editor. Commutative, commutative divisible, commutative, contramutative. Oh yeah, and I see what you mean. I don't know, because it's commutative, right? It's not true. Yeah, so that's a good point. So, contravariant divisible for now. And then if someone comes along and stuffs the poll, then we'll switch to something else. I really like this polling mechanism. Getting a sketch of what 30 some odd people think about what we should be doing is a pretty effective feedback mechanism. All right. Contravariant divisible, I don't need any methods. What are the instances? We know that predicate is a contravariant divisible. We know that equivalence is a contravariant divisible. I don't know what else is in there. They're in data functor contravariant. Oh, we have op. So op will be the thing that says if this thing is a commutative monoid, then op A will be divutative. I like divutative. You can just go with divutative. Contravariant divisible. I think that's everything that we actually have here. There's not going to be a whole lot of these classes. Or these instances. I just wanted to get the concept captured, because if this is going to be the library for commutativity, then it would be good to have it cover contravariant divisible. I suppose this should be data functor contravariant divisible commutative. But then also I should make control contravariant be that is a $10 name right there. Did I say contravariant divisible? Data functor. Oh, wow, I totally screwed that up. No, 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 yes, 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 yes. And I typoed this. Thank you for catching that. Albot. All right. So how are we doing? So we have commutative divisible functors. Sweet. Composition with a commutative applicative and maybe. So I don't have... so the problem is functor composition. When you have composition with a contravariant and a non-contravariant functor, or covariant functor, there's two ways to do it. So contravariant on the outside and contravariant on the inside both should give back a contravariant functor. And so if we look at package contravariant, I don't remember if I actually have packaged up a form of contravariant composition in here. I do. There's data functor contravariant compose. And so this does have the lifting over the applicative and divisible. So that's a good catch. We should add the data functor contravariant compose instances for compose FC and compose CF. So that's going to need contravariant and divisible. So we need control.commutative. And we're going to need data.semigroup commutative. So this one gives us the notion of a commutative monoid. This one gives us the notion of a commutative applicative functor. I lost my Twitch chat. There we go. So that's a very good catch to know. How do we do this? We say instance commutative divisible F, commutative G, commutative divisible compose CF FG. Make this a little longer. Instance commutative F, commutative divisible G, commutative divisible compose FC, FG, and I need to import compose. So let's get this thing to actually build. Commutative divisible, line 13. What did I start writing? Predicate equivalence, op R. No, we did op. Simplified class constraints, matches an instance declaration, monolocal binds. All right. This notion of something happened in GHC 8.4, and there was this old pattern that I've been using forever where you can say like class foo A, bar A, baz A. Instance. And then this made a strictly better version of a type alias, like with constraint kinds and stuff turned on, where you could technically say this before. But this version here, you couldn't talk about unapplied, whereas this version you can. It looks like 8.4, they added a thing where if you use this pattern and it pops up in negative position, now all of a sudden you need to have monolocal binds turned on. This is a really annoying regression because I'm going to find places where I have to add monolocal binds to all my code. And no, you don't have to capitalize pragmas at all, not them. I do it in lowercase. You can You can do it like that, so it looks more like they're all together. I tend to write them in lowercase because I don't have to hold down Shift. And I feel less like I'm shouting. So we have commutative divisible functors. No, the right-hand side, this part is case sensitive. The pragma names are not. And this is long enough. I'm feeling the pain of that, so I'm just gonna break this line up. I don't know what's the better pattern. We'll go all the way in. Yes. Works fine. You can cause eyes to bleed. All right, divisible, commutative, divisible. Is that everything we really want to say about commutative divisible functors? I'll split these up a little bit because they're looking noisy. All right, let's pop out of there. If I look up, everything seems happy on the build front. Let's just do a full build just to be sure. All new build. So let's look at some of these modules that we haven't talked about yet. So we've gone through and we've built up this notion of commutative applicatives. We've built up this notion of commutative semigroups and monoids. We've built up commutative contravariant functors. I also have a little module here that goes with the code that's in semigroupoid. So there's semi-applicative and semi-monad. They're currently called apply and bind in there, which I really should at some point bite the bullet and rename them to semi-applicative and semi-monad. So that they actually map onto something that's real in math, but that's going to require like a version 6 of semigroupoids and horrific breakage across the entire ecosystem. So I haven't been willing to do it yet. So that's what this little module is. And then we can move up to say, so I built a commutative monad transformer. So this says that if M is a commutative monad, then T of M is a commutative monad. And so what do we have that are instances of this? We have this concept of, well, reader T takes commutative monads to commutative monads because adding an environment doesn't change anything. And as long as you're writing out a commutative monoid, then writer in both of its forms are a perfectly legitimate commutative monad transformer. And identity T doesn't do any damage to anything's commutativity. So we're pretty happy with this. Then I come up and I started doing, there was the notion of list T done wrong. That's the version that's in transformers. So list T is buried in there, but it is deprecated to hell. It says this transformer is invalid on most monads, so let's fix it. Why is it invalid on most monads? Well, let's say this was I/O of a list of A's. When you actually go to bind inside of this thing, it's not getting you separate threads of I/O actions where you can carry on each one of them individually. That's what the list T done right stuff does. So list T done right is buried in the Haskell wiki, and it talks about how to build this transformer that inserts I/O effects or M effects basically at each level of as you go to peel out the individual const cells. Whereas this version just says screw it and smashes everything flat. These commutative delights have monadal ends. I actually, Cube Fox and I might steal that as the description of the package. If you don't mind. What is the attraction of doing list t done wrong right? Really, it's more that I can than that it's particularly great as a monad transformer. Commutative monad transformer. Monad trans A, monad trans B. Oh, that you want the ability to commute monad transformer layers themselves. So yes, there are numbers. There is the notion of I guess we could say, like, I would think of them as almost like the center of the category or the sort of type of monad transformers. They're the ones that you can commute freely. Reader, writer, state all commute freely, but if you look at either T or something like that, it doesn't commute with the rest. Maybe T has that problem as well. It changes semantics when you start swapping one over the other. Cont changes meaning and stuff like that. So yes, there is a notion of a properly commutative monad transformer. I don't know how to capture it here. So since I don't know how to state it in full generality, I'm not bothering. Yeah, that's true. So I want a trans of commutative monads. So, but since monad comes first in the name monad trans, I'm sticking with that name for right now. Is the specific transformation used by eval justified somewhere? So we haven't gotten to eval yet. So that's in the free monad thing that I have. As for is it justified? Yes, it's justified. It's actually sort of one of the ways to define what a free monad is. Okay, so let's go back to that list thing. So here we have sort of list t done wrong. This is basically the code from transformers lifted out. The only difference is we only pretend that this is a monad when M is a commutative monad. And then we don't do anything different. Where when this is a monad fail, whenever M is a commutative monad, not just a monad M. And so now you can use list t done wrong under reader and stuff. And if you look at it compared to the list t done right, when you look at it for the reader style cases, it's actually going to be rather drastically more efficient. Okay, so we've got list t done wrong, done right. And then the other thing I started to do was to build this notion of a this is not a commutative monad. It's a monad for given a commutative applicative functor. And the idea here was, if we just, what is the applicative for free of M? This line of code changes everything. Does it still have a monad trans instance? That's a good question. Should it? If M is a monad, so the problem here is this. Monad trans is wrong as it's currently defined. It's missing a constraint. It really should be that if you have monad trans T, lift takes a monad M and gives you, takes M of A and gives you a T of A, right? This should also have the constraint that says something like if M is a monad. For all M, monad M should tell me monad T of M. This is a missing constraint above monad trans. Because if you don't have this, you can't actually build the category of monad transformers, etc. You can't tensor them up. You're missing a bunch of things. Actually, list T done wrong lasted a long time before people noticed that it wasn't a monad transformer. When was the list T done right article written? (2007). The MTL predates that by a good bit. I didn't know that Yitzchak wrote the thing either. Yeah, it's kind of like how we didn't need, we didn't know that that map-M only needed applicative rather than monad. So anyways, this logically, with the new quantified constraints extension, we should be able to do something like this. And then this would just automatically work. So an example of a thought you can't think without this thing being a superclass of monad trans is you can't think the thought of how do you build the tensor of two monad transformers. I want to be able to take two monad transformers and build the nested monad transformer. So I'm going to be able to talk about tensor of reader TE and state TS. And this should be a monad transformer in its own right. It should, but it's not a thought I can think because even though M is a monad, I don't get to know that T of M is a monad so that I can feed it to S. So I can't lift here with tensor. If you go to write the instance of monad trans for tensor, you get stuck today. So we're missing something, and that fundamental thing that we're missing is this. And so this isn't legal Haskell today. This is legal Haskell tomorrow, basically. Does this solve my problem with monad transformer lenses? This solves the problem with, yes, the monad trans lenses, where you have to build. Currently, you have to use you'd have to use an extra constraint. I think I used trans or something in the talk. So the talk that Edmund Noble's mentioning in the chat is, where is it? I'll pull it up. Commit monad transformer lenses. It's this talk. So I gave this talk in Poland at the Warsaw, is it Monadic Warsaw Haskell user group. So as for how far special people, as for how far they are with implementing quantified constraints, Simon has a branch. It works. I would like it to be a little bit more liberal because once you have quantified constraints, there's a lot of things like how undecidable superclasses right now is super conservative about what you're allowed to walk up into in the superclasses. And it could be made a little more liberal. And if it can be made a little bit more liberal, then I can do lots of fancy category theory things in Haskell that I currently can't think. Do I know if there's an extension or a variant of Haskell GHC that makes it suitable for systems programming? No, there isn't at this time. So what has been done for systems programming in Haskell, there was for a little while, there was a guy working on a version of JHC, because JHC doesn't really have a garbage collector, it just uses the bum collector, that was designed for spitting out small system-like executables. It had a relatively small footprint and builds a very, very small executable. So he was doing that for a while. He eventually abandoned it and moved to Rust. There's also some work that was done on, I think it was called Atom or something like that, which was a little EDSL in Haskell where you would write Haskell code that would produce an executable that could run. So it was code for building these little super tight state machines that would then run on embedded hardware. So you would be using Haskell basically like a macro language for building this embedded domain-specific language that's going to run on the final target. So when are Monad Plus and Alternative and Friends going to become deprecated? Monad Plus does not actually technically subsume Alternative, because Alternative, we can't prove mathematically that Alternative implies Monad Plus if you're Alternative and Monad. It's an annoying subtlety. All right. Switch that Cokes here. So yeah, so monad trans really should have this extra superclass, and so when I built that commutative monad trans thing, it's really logically that you should have commutative monad. Gives me a commutative monad T of M. I don't remember what it was, lift commutative or something horrible. Commutative monad M, MA, TMA. So that's why I left off the commutative monad trans instance for lift is missing, because it would not actually be able to run through the version of tensor that you should have for here. This should exist, but it's not a thought you can think. So since monad trans doesn't have the superclass yet, hopefully in some far-flung future around 8.8 or something like that, we can bolt it in. I would be really, really happy. It'd probably be later than that. Because monad trans is buried in base now, I think. Yeah. So that's a change we could make. Commutative, did I say commutative? Anyways, this whole thing, all this stuff down here is getting eaten, so I'm not too worried about it. And as for PureScript, yeah, you have to be explicitly lazy, which leads to all sorts of lovely things, because you have where clauses that are kind of implicitly unstructured about their order. So, like, PureScript gets away with notation that they really shouldn't be able to get away with. Sure. So basically what we are doing is, this is a session mostly to get some Haskell live coding out there. What we've been working on is building a library for working with commutativity, where we have all sorts of things for talking about associativity in Haskell, semigroups, monoids, applicative functors, monads. All of those things happen to be some notion of associativity. We just don't have anything for talking about commutativity. So it's king of the house, regardless, like the strict lazy dilemma. I find generally that writing lazy code that uses strict data types tends to be a good enough divide. That works pretty well for me, at least. Line numbers might be good if code is going to be referenced from chat. It's good and bad. So what's the... for me, because I grab code like this a fair bit, it screws me up locally. So, yeah, okay, I'll set number. And I'll unset it when I need to cut and paste some lines or something like that if I'm going to dump things between files. I'll add it to my VMRC too. All right. Thanks, Muxidia. So what do we have? We have this list monad. So I guess we were just starting to get to the free monad. And so normally what this is going to do is you'd be able to say something like, this is app. So the free monad, given a functor f, is going to be, a or f of a or f of a or f of. And that's captured here by, well, here we call it FM. And it has the structure A or an M full of this thing, which is A or an M of. And yeah, it's a very Spartan VMRC. This is basically not quite a brand new machine, but it's only a couple weeks old, and I haven't really done a whole lot on it. Commutative, applicative. Okay, so commutative M. So what I want to do here is, instead of the normal free monads, which maybe I should pull up the two and compare them side by side. Would that be useful for folks? GitHub, ecomat free. And so far, we've only built the super naive encoding of the free monad. Yeah, so here we go. So here, same data type definition. Oh yeah, I'm missing all the... I'll just say generic and generic one. Since I'm looking to actually sort of productionize this, I should make it have all the things. And then I'll eventually have to add all the typable magic if we're going to start trying to backport this to old versions. So why the commutative constraint on the applicative and monad instances? So this is different than... So this version of the free monad is the free monad given a commutative applicative functor. And so what I want is for the applicative instance here to be smarter. Hold Alt while selecting. I think I have to set mouse or something like that in order to make that work. Yeah. Okay. I'll do that. VMRC. Because right now I was just letting it run with the system mouse. Okay. So where were we? We were getting at this notion of commutative applicative. So if I just started here, then this would just work with any monad or something like that. Because this definition just strictly walks underneath the functor. But what I want to do is I want to be able to work smarter. I want to use the ability to commute things so that if I go to glue two free structures together, well, they're both M of something, or they're the easy cases that are pure. And if they're both M of something, I want to take the outside M's and kind of commute them together. With the idea being that I want to be able to use all of the applicatives. I want to be able to see all of the applicative structure I can without burying it needlessly underneath a bind. So it's here that is the workhorse that we have, like here we have a MF is an M of free of M of F, and MA is an M of free of M of A. Let's A to B. And so what we're doing is we're stepping underneath these two things using lift A2 to get under the M's, and then we're apping this to this. So the outermost layer of applicative effects can now be merged together by exploiting the fact that M is commutative. If we just had applicative here, this would not be a legal thing. It would be doing much the same thing that list T done wrong did. And so once I've got this constraint on the applicative, I have to have it on the monad. And then we need to be a monad in order to be an instance of monad free. And I think that's everything we have. So yeah, so eval here is fairly trivial. So that, like, we can talk a bit more about what the definition of a free monad is. And is this thing a free commutative monad? Yes. Commutative M. And then we get to be a commutative monad for free. And that also means we are, so here's the problem. We are not technically a commutative monad transformer because we fail the lift law. So free is, how to put this? Free in the free package currently has a bunch of kind of hinky instances that I think need to just die. Oh yeah, I guess we also need to get like the foldable and stuff like that in there as well. If we're going to start doing... And by the way, I currently can't see the Discord chat, so if anybody's been trying to talk to me on there, I apologize. Currently have the Discord stuff up just for audio. Sorry, I'm just trying to see what people have been saying. If there's been a little bit on your comment on constraint kinds on Twitch. Partial. Okay, nothing terrible. Interesting. You see a lift M. Where is there a lift M? Lift M. I don't have lift M's. Lift M's. Oh, in the old version of Freeze code. Yeah, the problem here is that they needed to, this code needed to be portable to older versions of GHC. And so it predates like Functor being a superclass of monad and stuff. Currently what I would do is I would go through this and like if def every single line that calls it lift M. I just haven't done so yet. It's fine, but it's sort of there are plenty of places where it has a significant cost. All right. So where were we? We're looking for the applicative. Yeah, so here the applicative, all it can do is map under the M and then do an app. So all of this code should be basically the same. Pure A. Oh, yeah, I guess we could save a little bit of work by being careful to do pure and pure. So we save a pattern match until this thing does case-of-case analysis. Pure A. And this is the pure free MB case that's over there. Free F map F over MA. Kill some parentheses. Line things up in a way that I'll get yelled at about by Tonic later. All right. And yeah, the CPP thing you've already addressed. Okay, so we now have everything. The only difference here is this line. Is being split into these two things. Because we now know that it's safe for us to mash the M's together. I don't know that. I don't know too much about the Twitch groups, Jenny baby. Sorry. Yeah. Every time at work, I have carefully lined things up. He goes through and carefully unlines them up. All right. So we have commutative. I suppose since we have a dependency on the semigroupoids, we should build the apply instances that would be implied. fmap, lift A2. This is a bit of mindless repetition. No, I don't need that. I just need the instance com m bind. There. IMHG, basically what we're doing is, so we're working in Haskell. This is working out as a an effort in writing a library for working with commutative structures. So like if you have something like addition where a plus b equals b plus a, Haskell has all sorts of things right now for talking about associativity, but nothing for commutativity. So Taneb, as for how much the commutative free gains in practice, one of the major examples that I want to show is how to use this for a very efficient sampler for something like with Gibbs sampling. And for me, that will actually matter enough that I can turn things that would never finish in my lifetime to things that will finish instantaneously. So that's sort of been the working example that I want to get to. Lyle Cop, that is correct. Maybe it's commutative because there's only the one thing there gives a lot of flexibility. Maybe as a commutative, applicative works out fine because there's no with either it would have like an error message or something like that. Well, the idea here is that I want to use this with a commutative applicative for drawing samples from a probability distribution or something like that, and then lift this into this free monad. And the end goal is to say that if you write your code with applicative do, then the applicative do will nicely associate things and pull the apps as far out to the front as it possibly can, but it can't see inside your functions. And then using this free monad or something like this free monad would then let me see into those as well to gather all of the effects that I can, all the information on all the effects that I possibly can in advance. Okay, so we have eval. Eval is not strictly written in its most general form. As an aside, did you see the weird monad to Commutative transformer you came up with? King of the Homeless, I did see the Commutative transformer you came up with. It is, I believe you have something that should be legal. The thing is that it is not technically dual to co. What you have is like, I have to look at it again, but I believe you have something like the can extension. I don't remember if it's left or right, but you had a can extension of like w along w.f or something like that, where f is a monad. It's something like that. I have to actually look it up. I'm not going to be able to do it live on the stream. A right associative version of star. I'm not quite following. If you have Commutative, you can use this. Yes. So the idea, Urson, is that if you're working with this free monad, the idea is I'll be able to take, if you had underlying commutative applicative, you can smack it with this free thing, and it'll gather as much of the commutative effects up to the top as it possibly can. That's the mission. I haven't actually tested to see if this works. This started out as a stream of consciousness like 3 days ago, and I sat down with Ariakanem and we did like a couple of hours just on a pair programming session over Google Hangouts, and I sketched out what it looked like and had a pile of instances, and then on the stream the other day we built the basic library that we see here. Yeah, rewriting less than star into less than star star, like using something like lift A2 or something like that is a little more symmetric. There's a reason why when people start building free applicative functors and stuff like that, they tend to want to associate things to the other side anyways, and it's largely because you want to have access to the effect on the left as quickly as possible, because it's usually ordered in that manner. Yes, I said the dual of co would be impossible to do in Haskell. The thing that you have is not the dual of co. That's why. That's why you can write it. You're giving me a way to smash the effects flat, which is not the dual. Commutative monad free. We have commutative trans. Oh, we don't want this to be a monad trans. That's right, because functor should not be a monad trans, or free should not be a monad trans. This is not a true monad transformer. This is one of those places where I lied to myself and I feel guilty. How do I pronounce my last name? My last name is pronounced Komet. So we built foldable, we built traversable. Since we depend on data.semigroupoids, we should be really careful about bidding. How do I pronounce my first name? Edward. Data.semigroup. These instances are not terribly exciting, but I need to get them built anyway, so if I have to suffer, you have to suffer. Fold map 1F pure A is first one, pure A is well, that was boring. If I understand it correctly, the commutative constraint will enhance the simplification heuristics used by applicative do. So Akram's the idea is applicative do doesn't know anything about your commutative constraint. What applicative do does do, though, is it tries to get you as many apps outside of your binds as possible. And that's because of the cost function that we came up with when we were able to do applicative do. Basically always says that if you can use an app instead of a bind, do it. And it tries to pull on the outside of your function. It's going to like collapse things into very small bits of data dependencies. Just misspelled instance in there. I did. Thank you, syntax highlighting and my inability to pay attention. Thank you. Curved. Yeah, I can't pronounce your name. I'm sorry. I'm not going to try. So as for the commutative constraint simplifying applicative do. So applicative do won't be able to use the constraint itself, but what will happen is it will still get me applicatives on the outside, and then the applicatives on the outside will be able to mash together through this slightly better app that this particular free monad will have. and then I'll be able to see the example. So Ariakanum, you had a little example that you had already worked up. Can you paste that if you're still around? That would save me some time. Yeah, I'm not going to fight the Vim Emacs wars here, Malk. Because I haven't gotten around to building any sort of test examples. Might be worth it to start trying to get this thing to run on Travis, but then it's going to goad me into wanting to do older versions of GHC as well. And then we're going to have to deal with the fact that semigroup is not a superclass of monoid on old GHCs, and so all of the semigroup code is going to become horrendous. What is foldable 1? Morally, foldable 1 is related to folder 1 and foldo 1. Data.semigroup.foldable exports this class, and it's a things you can fold with an arbitrary semigroup. So if you can turn A into a semigroup M, then you can turn T of A into M. So it's the thing that you can use for working with non-empty. Especially people, I don't know if you're being sarcastic, but you're welcome. We did take 3 years to get around to doing it. So foldable 1 is exported in semigroupoids. And there's also a data.semigroup.traversable, which can be folded with an arbitrary semi-applicative, which is what we call the apply class. There. So here you just have app, you don't have pure. But since apply or semi-applicative is not a superclass of applicative, traversable 1's a fair bit harder to use. Now that semigroup is a superclass of monoid, foldable 1 is pretty usable. So if you look in the lens code, there's a small snippet of lens code for working with these what did we call them? Relevant lenses and the like, where there are relevant traversals, where you have a traversal that is going to return one or more things that you can't fail. And there's even less code, I think, there for dealing with whatever we call the affine traversals. Mostly, so the main audience of this is a lot of Haskell folks. We have a few people who are outside of the Haskell community, I freely admit. I think we were split 60-40 Haskell folks to 40% extra for non-Haskell folks. We've lost a few, so I'm guessing we've lost a few of the non-Haskell folks a little bit at a slightly better ratio than the Haskell folks. I apologize for that. And you're asking, I'll try and explain with some greater details. There's going to be some detail lost as we go. I will definitely, I think what I'm going to try and do is keep this session maybe about this level, maybe a little bit slower, and then try and set aside some dedicated sessions that are targeted explicitly for newer folks. And on the Discord, I've set up, we added some mods and stuff there, and we can probably set aside a little side channel for much more tutorial content. Because I think there's value to having high-level content on Twitch, but there's also value to getting more people into the community, and it's a tight wire act. I don't know how to serve the needs of both audiences well yet. So this is my first real official broadcast, letting everybody know, hey, look, we're doing this, and there's a lot of tweaking to do. So if you can think of what might work we might want to think more about how to do a more presentable tutorial content. Yeah, so far, basically, my goal has been to say, well, if you know what Haskell is, you know what type classes are, and you know your way around applicative and monad and stuff like that. You may not have to be a category theory expert, but you should be able to follow. That's been the level that I've been targeting so far, with the idea that if you're coming in below that level, you can kind of let this wash over you and get a sense of what day-to-day development is in Haskell. And I may have set the bar too high there for some people, but I figured it was a level that I could serve my existing audience well and serve others passably. And then I guess we'll do a more narrowly focused tutorial session at some point. Yeah, this is pretty close to what I do day-to-day area econom. So I figured, like, because it's you just don't normally get to see what a Haskell developer works with, the GHCID and working in the tools and stuff. This is reasonably close to what I do. Is I sit down and I write libraries that I think should exist because some deep fundamental mathematical reason, and then I start backporting them into application domains. We have bind. There's a bind trans as well, but this is not an instance of that. And so yeah, so sort of. No, this is a new package. His equals he is. I don't know where that is. Just scrolling back. All right. It's 2:15. I've been here for about 2 hours. Let me take a quick bio break, and then I'll be right back. I don't have my... I'll just throw the media file up blind. All right, I think I'm back. Hopefully this transition doesn't destroy my machine again. How are we doing? Where's the straw poll? Woohoo! We managed to survive one more screen transition. So as for tooling, I did spend, I did it as a pair programming session with Viho Cigar, who's in the chat right now. Hi, Dan. We are trying to live code a bunch of Haskell. So we have bind, monad free. What are we missing? Okay. So we have the free monad given commutative applicative functor. We have our fancy instance. And then, do I have opinions on Rust? I think Rust is in many ways heading towards being the best that it can be given the constraints on what it wants to be. Space max is like evax with evil mode. Cop. I can't fully parse that here. However you write it so close to the arrow, you get a fluid. Is there an alternative way formulates applicatives with a different operator that could truly be commutative? Yes, you can define a applicative with lift A2. What we do right now is basically we start with sort of we go there. What is this? Dot uncurry. Dot curry. Yeah. So here we can see this. If we use the symmetry or the ability to swap arguments for tuples, this is the same thing as using the ability to swap arguments over here. Well, with lift A2, basically all I'm saying is that functions, I can flip to swap the argument order, and I can flip to swap this order. And it doesn't matter. Yeah, fair enough. I use normal Emacs, but I've been using yeah, I stick to Haskell or to Vim mainly because I've been using Vim for 30 some odd years or something like that, or some flavor of VI, not Vim. So Eric and you pasted a link earlier, but I lost it. One sec. Had to blow my nose. I didn't think you wanted me to do that into the microphone. Thanks. So I'll pull it up on the stream. Commutative I/O. Oh. All right. Lyle Cup, I think we've been talking about two different things. What I've been talking about is that lift A2 gives you a form that is more obvious how do you commute. You don't have a applicative commutative functor by default. That's what the commutative class that we have here is for. So what do we expect applicative do to do here? Let's go look at the math of that. What is lift here? Lift is the thing that takes this and dumps it into... Oh, you did add an instance of monad trans. That's a $10 word. I got us 1, 2, 3, 4. Oh, I didn't turn on applicative do. One, two, four, three. So it actually did do a commutative thing, but only with the return. So let's look at the cost function that is being used underneath applicative do to try and figure out what's going on there, because I don't actually know what's happening here. And yeah, the name is horrible. I tend to avoid random abbreviations just because they become awkward points where, well, is this lift contravariant, lift, like the, who knows, co-lift, right? Like all of these things are possible choices of C. Rather than turn on commutative monad M. Oh no, we need monolocal binds. Thank you, GHC 8.4. Really not happy with that. Okay, so we at least can write this down short. So this is going to see that this is a small computation. This is another small computation that doesn't depend on it. And then it's going to try and app this thing to this thing to this thing. And it's going to leave this bind intact. But what I want to do is, I don't actually want to see it this way. This is not informative to me. I want to see... do I want to see LC put Sterling? I want to see something like... I want to see this thing as a function. And then have applicative do... Because applicative do doesn't know that these things are different costs. prime, 1, 2, 4, 3 unit. One, two, three with the function for. So why is it doing the 3 on the outside? What are we doing wrong? So I have an app of a free thing to a free thing. And yeah, applicative do is going to factor some binds into the app, and then it's going to use join to smash them flat, which is perfectly fine for us. So this is the problem. Here I'm trying to problem solve here with a nice 130-person audience. What do we have? We have, this is obviously correct, this is obviously correct, this is obviously correct. This was my intention of this whole thing. When this wasn't working, you got the idea to add the return from reading the applicative do wiki or something. Let's go look at the applicative do wiki. So, first example, do two things, return, turns it into an app, which we want. Through the unfortunate magic that has to exist on top of return. Final statement doesn't have a return, then we need to use a join. That's true. Oh, are we seeing something where nope, the final statement doesn't have a return. Oh, so the final statement doesn't have a return, so it is turning into a join of something. And then the inside desugaring. Is there any sort of debugging that was added for applicative do? What do we call it? Applicative do. GHC command line. That's how I found the f-optimal applicative do thing, which gives me my algorithm. There's nothing that actually shows the output of applicative do or anything. Am I aware that Twitch deletes saved broadcasts after a few weeks? Yes, I'm actually separately recording locally to create a local master, so I should be able to upload this to YouTube as well. So that even though Twitch will delete me in 2 weeks or 3 months or something like that, I don't know if it's going to upgrade the life after I become an associate or something, if I manage to do that, whatever, or affiliate. Then we'll still have the archive. All right, so there's nothing here for dumping the associativity information for applicative do. This is where Simon and Andrei Markov and those folks who were working on the applicative do stuff did all the work with actually seeing what GHC produced. So I don't actually know how to get the dump that I want. I guess I could go all the way down to core and look at the thing that gets dumped out, but that's going to be damn near unreadable. Anybody have any suggestions here? Otherwise, I'm just going to stare at this and try and think really hard, which is always a great audience spectator sport. So eval of do of this lift is going to try and turn that into this is going to turn this into something like join of, and then it's going to build a big app that's going to build the last lambda calculus case there. LC put stir. It's going to ignore the first two arguments or something like that. Give me back LC of put strlen 4 or something like that. Oh, that join is awful. Your suggestion is to invent a time and prevent applicative do from ever becoming a thing. Is this one of those things where I'm supposed to repent for my past sins? I just think this join winds up being a really horrible piece of sugar. Because it shouldn't need a join. This is forcing this to be a join rather than using the fact that it's giving back unit and doesn't need to. So this looks like a bug in applicative do, that it's trying to use that join. I mean, it's correct that it's legal to do, but the last action is an applicative action, but it doesn't depend on anything. If the final statement doesn't have a return, then we need to use a join. That is false. Isn't applicative do smart enough to recognize that it could use the star greater than? It is unfortunately not at this point. There was actually a GHC track issue that I created to say, hey, look, we should do smarter things with applicative do, and how it should desugar more things in terms of less than star and less than dollar. Applicative deep doo-doo, yes. So why do we have that join? We don't want the join. Whoever put the join in was not in the, it was not part of the original discussion of this. Do B, and then return a do notation. The return. So that was something that we didn't talk about. The join was added after the talk about the paper. It's a bit of a deal breaker for me as well. Because the star grader is so much more efficient. There's a smarter GHC track. Trying to search with symbols on Google is going to suck. Do we have, was there an issue list here? Yeah, here it is. 10892. Would it be possible to, and then I think I gave a sketch of how it could work in the comments, but we never got around to implementing it. It's not happening for 8.4, but it might well be done for 8.6. That's what Ben wants to do. So if you're interested in the dump TDS, let's see if I can do this. Do I have a GHCI here? I have to build this thing directly in order to do it. What's the 10892? Yeah, I'm not going to try and read dumped core on live on the air. Can you do ddump ds on GHCI? Yeah, again. Let rec. Oh, the parse expert is not giving me anything. Oh, I can never remember this. And Shakov didn't join the chat. Shakov's the guy who's always been my, hey, I need to read this core thing, and he just gives me the command line options to pass. I should really learn how to do that at some point. Dedump simple, that sounds plausible. What is this stuff? This is... What's the -f no code or whatever that you can use for GHC? What's the thing you use to get it to build without code? Do you know? Evil. Thought it was -f no code. 24. Oh, this is me. I just left crap in the stream. So I did have it right. IO main is not defined. Well, this is main now. There we go. That's what I wanted. Eval. App bind. And this thing on the outside is the outside of an app. So this is actually producing the right code. Using the applicative, and this thing's built a bind inside of the structure. And then we're doing the thing on the outside. Yeah, that's the problem with as I chatter, I tend to scribble like stream of consciousness code in the editor that I have access to. So this is producing what we'd expect, but this was with the return. Let's see it without the return. Here it's doing a join because it's stupid. Okay, so this is just applicative do is awful. So there's a problem with the join desugaring of applicative do that I think we need to figure out how to phrase and then file as a GHC track ticket, which we can either try and do like now live on the air, or we can and collaboratively edit the words, or I can just file it offline after we're done. Because that join thing is stupid. What's with the return unit is the track isn't smart enough to, or the GHC is thinking that it needs to put a join here for some stupid reason, because it thinks that this thing depends on the variables that came before it, but it obviously doesn't. So the rule, whoever thought of the rule for putting the join in, well, the workaround is just bolt the return on the end. And you can't. And what's worse is you can't even do this. You can't even say, no, I really mean it. So that case 2 on the applicative do article is just total garbage. I mean, it's correct as long as this thing actually depends on the stuff above. But it should not be using join for something that is clearly applicative when this thing doesn't use the previous arguments. So let's track live. Fine, I'm logged in. Let's check the tickets. The bindable syntax should not eliminate return. Should eliminate return and pure. Yep. Starting your ticket. Let's just desugar this down into the raw I/O example. So that I can have a nice I don't want to use, and I failed to use the alt thing. Foo equals do, crap, 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 crap. I'll just start here. I'll just describe it abstractly. Alt. You're asking whether you can have a Q&A session with me? Absolutely. Probably the best way to do that would be to join the Discord server, because that way you can actually use voice. I'm just going to make these something like this. I don't even need C3 to... I'll just stick to that. ABC, A1, BC, 3. The last clause is a return or something else, and then bolt a join in if it isn't return. This check is too conservative. If it isn't a return, but doesn't reference any of the variables above, you can still desugar it with app. We this a Twitch live stream in front of a studio audience, or this is the wrong syntax for track. That looked plausible. Return produces very different code than, for no good reason. Currently, we check to see if the last clause is return or something else. And then bolt a join in this if it isn't return. This check is too conservative. If it isn't a return but doesn't reference any variables above, you can still get it. All right, so this is, that's a bug. Somewhere in the code gen, I guess, I don't know. Yeah, Herbert fixed it, thanks. And yeah, I realized that you're lagged 20 seconds, so. All right, what are we missing? It's a bug, milestone 86, blah, blah, blah. We know this currently affects at least 842 and older. Is there a way to say multiples? I don't know. Yeah, that's good enough. Type bug, me, operating system, everything. All right, ticket exists. We've now created 4 tickets so far on Twitch. Some keyword for applicative do. I'm not quite sure what I follow at Adam X Adam is asking. Tried that foo in 802. Was it, let's see here. Let's go back to, can I compile this thing on 802? I want to compile the whole commutative kit and caboodle. Let's go, fix this package so I can compile all the way back to GHC8. I think I have, what versions do I have? I have 8.2 on this machine. I don't have an 8.0. With put Sterling, I think you're going to get the same output because I/O is going to be super fancy about, it's going to inline all the way away. So you're not going to see any of the apps or the binds. That's one of the reasons why I was being careful to put the like abstract ABC things. Yeah, the problem with greater than and star greater than is that historically a lot of people had implemented their implementation of the applicative star greater in terms of greater. So if we try and pull greater out of the monad class, and then what you're going to find is all the people who had implemented their less than star equals greater are going to start getting random spins. And that's one of that's been the main point in removing it. If we remove it completely from the language, that would be fine. The problem is it has a different precedence than star greater. So there's an awkward transition there from a standards standpoint. When typing, do you follow rules like the touch typing ones, or do you just go how you feel? I don't. I type like a mutant because I learned how to touch type, but I always feel like when I use Vim, my hand creeps up towards the escape key too much, which actually is one of the reasons why I'm working on this little MacBook rather than on this MacBook Pro behind me, is because the touch bar drives me absolutely insane. So when I set my hand on that bar where the escape key is, because now just physical contact with the key, even without depressing it, causes it to go off, I've launched emails and ships and all sorts of crazy things. And yeah, mapping escape to caps works, but my muscle memory isn't there, so I still sit there and hammer the space, and it doesn't work in everything, and yeah. I still wind up getting problems in my editor, or in my like browser and stuff, just because my hand sits there. Yeah, if you look at this is set up to have the same fixity as bind, and this is set up to have the same fixity as less than star greater. And yeah, Lorax, we do watch Critical Role. It's one of the... It was the main reason why we had like the Twitch account set up. All right. So where were we? before we kind of got derailed into applicative monad horribleness. So I guess the solution for now is just going to be that if we want to have applicative do produce good code, we're going to put a random pure at the bottom of the, or pure return at the bottom of each of the function definitions, which really pisses me off. But this is when we find these things. And yes, it's just like Scala. Oh man, I can't escape. What was the track number? 1500. If I think about it, the whole goal of this was to try and start exploiting applicative do. The join is going to cost me a lot asymptotically in some of the examples I want to try and build. Oh shit. Okay. So once we get past that wart, what else we got? So maybe we can try and motivate this with a sketch of how might I use this commutativity. So now that we have this notion of a commutative applicative and the commutative monad that results, I get to give kind of my usual rant about Bayesian sampling and whatnot. So maybe, how do I want to do this? Anybody have a suggestion of like a good like whiteboarding app or something like that that I can just randomly scribble on? And yeah, using the applicative operations by hand would be fine. It just means that this example that I'm going to give is going to be less cute. Unordered traversable. You'll be able to do things like bags and stuff. What else would fit into that? Sets won't work. Yeah, because you need idempotence. If you have an idempotent class, which will be probably another project after this, then you can actually have a traversable that works on set. You'd need a traversable idempotent. Or a commutative idempotent applicative. And a lot of the things that we have as examples here for the commutativity stuff also are idempotent. Yeah, so just freehand draw IO. Let's try that. All I want is just something that I can just randomly draw lines on and stuff. Save diagrams to, sure. Maybe I have to do this in another window so I'm not authorizing on the big screen. Create a new diagram. Blank. Sure. Can I draw? Twitch. Select. Pick a folder. No. Yes. Create a blank diagram, please. All right, I can draw lines somewhere here. Where's the line tool? I just want a pen. I don't really want to draw diagrams. Sketch IO, sure. Can I draw here, please? Give me a pen tool. That's all I want. Great. Yay! Well, that's way bigger than I want. Path crayon. All right, can I shrink the size of that thing? All right. So let's talk about Markov chain Monte Carlo, which is sort of my motivating application. So let's say you have some function. Now, this is going to be my number line. And it goes like this. And what I'm looking at is I have this function, the integral over this whole area is some constant. So the area in this, like the integral in this shaded area, that it's not really well shaded, integrates out to some constant. So the integral of f of x, wow, this is kind of awful, dx is a constant. So I have something that's proportional to a probability density function, but it's not actually a probability density function. Okay? Then one of the ways that you can draw samples from this thing is to say, well, if you start with a point, say x down here, such that you know that f of x is greater than 0, what you can do is, if you were to like perturb your point x by like adding some kind of noise to it, like adding like a normally distributed function to compute like a new x prime, and accept all of the moves that went uphill and some of the moves that went downhill with probability proportional equal to the ratio between the height of the old position and the height of the new position, then what you'll do is you'll satisfy something called detailed balance. Okay? And that gives us a, at that point, assuming that it's possible by using this walk, so what you'll do is you'll either stay at x or move to the new position with probability equal to the ratio between the new position and the height of the old position. So uphill moves have a probability greater than or equal to 1, and downhill moves have a probability less than 1. And you just kind of pick a random variable and check to see if you're going to stay or move at each step. So then if you were to look at the samples drawn in this fashion from this, assuming that it is possible to take steps with this probability distribution that always can always reach probability masses, like no islands that are completely isolated that this distribution won't be able to cross the gap. If this doesn't happen, then what will happen is if you were to close your eyes long enough between individual probability, its probability is clamped to 1, but you can just morally think of it as, you know, except with if a uniform variable between 0 and 1 is less than or equal to the ratio between the new and the old, the new over the old. So this is what we're trying to build here is something called Markov chain Monte Carlo, or MCMC. Wow, I'm totally should be using a text tool. This is just me trying to randomly sketch the goal that I have. Okay, so here what we have to do is we have to accept or reject entirely. Now in multiple dimensions, if I had a much bigger problem space, then what's going to happen is like, well, this is not a diagram I really want to draw, but I have some big probability distribution, and then there's like little hills and valleys in here, and I'm not going to be able to draw a nice contour map. And I'm going to be taking slices through this, which look like some kind of probability distribution with heights and stuff. And then I'll hold everything invariant and move in one dimension, then the next, and you get Gibbs sampling and all this stuff. But if you were to try and make a move, let's say I had just a two normal distributions. I have a normal distribution on x and a normal distribution on y, which I'll just also draw as a separate normal distribution. And I started at some point down here on the curve and some point down here on, or some point, say, here on this curve. So I'm at X, I'm near the middle. And at Y, I'm way down the curve. Then what's going to happen is my odds of accepting the new probability are going to be equal to the probability of accepting this one times the probability of accepting this one. So if I have a 250,000 dimensional thing, I'm going to be multiplying a lot of things together. And when I go to do all those multiplications together, my odds of accepting any individual move are going to be vanishingly small. Okay, so what I want is the ability to move in X, because X is completely independent of Y. They're just two completely independent Gaussians. I want to be able to move in X and accept or reject it, and then move in Y and accept or reject it. And what I can do then is if I have this applicative for, let's say we have a monad for doing Markov chain Monte Carlo style sampling. If we have the if we can exploit the fact that it doesn't really matter the order in which you draw samples, if we can exploit the fact that this forms a commutative applicative, then what I can do is I can pull all the applicative stuff out to the top, and all of the applicative stuff are samples that are being drawn independently of each other. And so I can do those walks and accept or reject each of the individual dimensions of those applicatives independently before walking down into the monads and all of the values and stuff that are dependent on the previous samples. Anyways, that's been sort of the motivation that I have for exploring this idea at all. So earlier on the Reddit, somebody had asked, why do we care about having commutative applicatives and stuff? I care about it because I could write code in this free monad and get better output. But then the important part here is that if I have a sufficiently large problem, if I just tried to use the monad and not the applicative, yes, I'll get the answer, but I may not be able to get the answer in my lifetime. Get a second some note paper. I actually do. I have another webcam. I have another desk even, and so it is a possibility that in the future this will switch over to using paper and a properly set up webcam and stuff. I actually have some fancy lights over here, and I have a green screen coming, so I'll be able to avoid taking up quite as many pixels of the shot in the future as well. A blackboard is a possibility as well. Okay, so we at least have a sketch of what my motivation is. Associativity gives me free parallelism. I don't know that I'd buy that. Associativity lets me share work in many cases. But yeah. So Edmund Noble mentioned wanting to be able to traverse a set earlier, which did make me think that maybe we do want to, at some point here, start building up idempotence as well. It's not going to be relevant to the particular nice case that I have here, but I think it might be a much more accessible example. Do we want to try and package up idempotence? Also, how are people feeling about how long this is running? Because I did say on the thing that it was going to run for a couple of hours, and I've now run a little over 3. So I'm trying to get a sense of how long should this stream run in the future and now. So you know what? We have straw poll, and it's been working out really well for us. So. Lyle, I confess I probably will run longer than 1 hour. I'll put a note in. And so as for time here, I'm meaning time from start. So right now we're 3 hours into the session. I love the couple of just earnest 6-hour sessions there. Do you want to put it on YouTube later? No hour than 1 hour. Well, yeah, I just wind up cutting things up when I need to put them on YouTube. And yeah, this is how long should this take in the future generally? So 2 hours is a nice consumable block for people. The thing is, I tend to get large chunks of time in which I can work, or I get stuck traveling and a bunch of other stuff. So I won't be able to do lots of little 2-hour sessions. I'll be able to do a few big monolithic ones here and there. Pick me with a background. I'm afraid of what Amy has. Ah, yes, that was taken at Jet. And yeah, it is a bit hard to find things in multiple, or in a gigantic 5-hour stream, I admit. Can we have the stream run all day? My wife might be upset about having to wear clothes around the house all the time. No. Tiny break after every 2 hours. Well, that's basically what we did. After the first couple of hours, I took a quick bio break. Yeah, in theory, when we upload this, we can upload closed captions, but that would require like some serious crowdsourcing, because our previous efforts towards it, Amy had gone through and started closed captioning the lenses, folds, and traversable talk that I gave at New York Haskell. And I think she gave up about an hour in, because then the captions start getting really special. All right. The fact that we have to do that return really takes the wind out of my sails, though, right now. Write an AI to create caps. Isn't that what Google did? All right, I'm going to need to take a break for a couple of minutes. I'm starting to chafe under the headphones here. Since I'm already chattering on Discord effectively by accident, I might as well come back. That pick was taken at Jet at the New York Haskell Hackathon, whatever they call it. Compose conference, unconference bit. So one of the developers there at Jet handed me a whiteboard marker and just told me to go nuts on the wall, on the window when I was looking around for a whiteboard. Sorry, Milk. All right. So we have this applicative view problem that's causing our free monad to not be as free as we would like. We had that sketch that showed when we really want this ability to draw samples from different dimensions and then mutate. Figure out how to encode this as a nice monad. I haven't actually figured out I haven't built a nice little MCMC monad in Haskell. So I'm not quite sure where to begin for that. Maybe that is a thing that we will do next session, because I'll have some time to sit down and sketch out some thoughts about how one might implement it, and then we can finish that derivation and run from there. Other things that I would like to go into, I started playing around with the idea that we might be able to use the stuff from Backpack to implement the kind of SPMD on SIMD stuff that I talked about in... let's see if I can find my talk. HSR, Haskell, Commit, SIMD, CPU. So I gave this talk, and this talk is entirely in C++. But it talks about an approach that I really want to be able to write code in Haskell. I just pasted the link in chat. And I have gotten to the point where I believe now with... I believe Ben told me that we'd finally fix the GHC calling convention so that you can pass 256-bit and 512-bit things in registers on AVX2 and on AVX512. Which would mean that in theory I should be able to write code that is particular to some instruction set architecture for dealing with like SIMD style code in Haskell. And we have like the int 32 times 8 hash types buried down in GHC prim. And so my thought was that what I could use is I could use something like Backpack to pick, you know, int 32 times x, whatever the thing that I want to be x wide, and then compile separately against each one of those. So you would build your code as a Backpack module that is independent of the choice of SIMD width, and then you would then instantiate your code as a Backpack module several times over against the different Backpack implementations that we have that I could supply for those different widths. So this is a thought that I kind of want to think, and I want to get it into some form that we could use in Haskell. I have some concerns, though, because I can't really set up... how to put this? I can't tell GHC that it should compile this module with different optimization options. And so I'm not necessarily sure that that project will actually go anywhere. It's kind of a pie-in-the-sky project for me. The other option is to use something like LLVM and then spit out dedicated code from some EDSL that describes the kind of SIMD computations that I want, but then it will always be its own little second-class citizen, kind of like Accelerate or something. So there are those options. There's sort of the capturing idempotence like we captured commutativity over the last session in this one, so that we could have something like the commutative idempotent traversable. That would make what Edmund had mentioned, like the ability to traverse set, finally a reality. I don't know. Open to what folks want to do next. I'm going to throw this open, and I think what we'll probably wind up doing is we'll use this time to do a straw poll session, figure out what we want to do in the next session, and then turn this around into just sort of an open Q&A for the rest of this. Maps probably still don't make sense. Sorry. I know you're a Scala person and you're used to being able to do so, but and I'm teasing you about being a Scala person. Next topic. Or topic for next session. What do we want to do? So we have SPMD on SIMD. We had the idea of exploring idempotence. This gives us traversable sets. What other options do we want to do? Just a general introduction level session or introductory. Any other suggestions for what we want to do for the next session? I'm currently in the process of just trying to write the straw poll. As soon as I add all the options to it, we'll throw it up. And so at this point, any other major suggestions about what we want to cover next time? Oh yeah, the MCMC monad that we started to sketch this time. Avoiding GC while programming in Haskell. I am not the best person for that. And intermediate level session. What else we got? Anybody else? Otherwise, I'll throw a poll open with these options. Oh, why laziness? I think that would fit into a general introductory level session. So if you're interested in that. What other things do I want to do with Backpack too? I have a bunch of things that I've been doing with Backpack in Coda. We built unpacked containers. So there's more that we could do there. Backporting commutative to older GHCs. Testing. Way to explain the levels. What else you got? Lenses. Allow multiple answers. Yes, I can. You can send me a whisper here, I think. I don't think I have those blocked. So I'm just going to throw this open here, and then we'll start There we go. So there's a straw poll for what do we want to cover next time. Are there any of the GSOC projects that I'm particularly interested in? Well, I'm helping to mentor the project that we have for AD. FGAS's project for adding multiple exports to a single Cabal project is probably the one that's going to have the most immediate impact on me. As for, let me pick something here. I want to finish the MCMC monad at some point. That would be great. I do like, that is the thing that's in my head. Item potence I like. We can do some boring backpacky stuff. Backporting this to older stuff. I don't care about the lens either way. We can do it or not. Oh, the ersatz library would be an interesting topic. So if we want to, what I can do is I'll throw the floor open pretty wide until, say, 4 p.m. my time, which means another 20 some odd minutes for just general... Oh, you're the one who has Lambda bot, Puff and Fresh. I have Lambda _ bot. I had to take it because I couldn't use it. I couldn't use the Lambda bot one. So if you want to take over dealing with Lambda bot concerns, then I'll just stop running Lambda bot myself and we can use yours. I was trying to... There was just no way to really contact LambdaBot to say, hey, who are you? And can we use you for the chat? So now I know who to talk to. Thanks, Brian. So a general intermediate level session sounds like the idea for next time. Well, let's see if we can get some of that out of the way this time just by using the last 30 minutes. Oh, you have... Yours is ProFunctorBot. Who is the one who's the person who has the LambdaBot account? I have... be careful because I have she should still be running unless she crashed. Yeah, apparently it had a hiccup. Yeah, okay, so LambdaBot's back. But I'm not wedded to running it myself, so. If you want to take over that. So, general Haskell questions or intermediate Haskell questions, I'm happy to throw open the floor. If you want to ask by voice, feel free to hop into the Discord and just chat. If you want to ask here in the... Yeah, Puff and Fresh, that's even after I expanded the timeouts from 3 seconds to like 15 by default or something stupid. I don't know what's going on there. It works locally, but whenever I try and do it through the Twitch chat, I think maybe the extra latency you get from the Twitch gateway or something like that, adding probably 10 to 15 seconds in the front. Are refinement and dependent types the future together with SMT solvers or not? All right, so Erson, you were the one who had the question about F star earlier. So using some kind of thing for SMT solving to handle stuff like BAPA, stuff like that, in order to handle questions about natural numbers and the like. Like F star isn't necessarily where I would tend to go towards for that. Like the stuff that's been being done with lean is really where my head is at. As for F star, I think it's an interesting. I like it better than I like F sharp, but I'm still a laziness is the right default for me kind of person, so I'm not going to be writing a whole lot of code in it. As for refinement types, I do find that in general, refinement types aren't as first class as I might like. Like if I try to do, like it's really impressive what you can say with the liquid Haskell code that's out there. But I'm not necessarily thinking that I want to write all of my proofs that way. If that's at all useful. Dependent types are interesting in the sense that I really like, I like having access to dependent types, but I don't want to write most of my code with them. One of the things that I find is that when I write a lot of code in dependent types, I find that all code reuse goes to hell. And so the level of parametricity that I get in something like Haskell tends to be very well behaved with, question mark is going to be, by the way, Puff and Fresh, question mark is going to be the command prompt things. Like you would use it with like @ in Haskell, or on our Haskell. Whereas the greater than is going to be the eval like normal. You think instead of testing the future is improving code? I do that now. I use very little testing, and I use a lot of parametricity and such to reason about my code. Okay, what I'll do is I'll kick LambdaBot out of the channel then. And then I will only bring her in myself when you're not around to run ProFunctorBot. Okay, the best and worst things about Scala. I gave a rant about Scala. It went somewhat viral several years ago. It was recently updated by Stephen Kompel. I'm pretty sure if I Google commit rant Scala, this will give you an off the top of my head list. Do I think co-effects are a good thing? I like co-effect systems better than effect systems. And Simon Michael, I'd happily go through what my setup is and stuff like that. I'll probably do it as a separate blog post or something. And I can't say that I've mastered it. It took me 18 minutes to deal with technical issues at the start of the stream. And all of the fancy stuff that I'd set up to do graceful transitions and like have all the links to things and show who's clicking follow and stuff like that. All that stuff just blew up. So it's not working as well as I'd hoped. But I can fix that for the subsequent sessions. This is the minimal thing that I can get running. What have I enjoyed about streaming? So this started out as an experiment in pair programming, not streaming. What happened was there was a Wizek had formed had asked a question on Reddit. It was, would anybody be interested in pair programming? And one of the things that I'd kind of missed about working at Standard & Poor's, which is where I was at before I moved over to Digital Asset, was there I had the ability to just pair program with Dan Dole, who's Codolio here. And it was a really effective experience. We got a lot of stuff done. And I missed the sort of forcing function of having someone to pair program with. And so Wizek set up the Haskell pair programming getter, which is linked below this chat in the panels. So there should be a panel for the Haskell pair programming getter. So if you're interested in just finding someone who knows more Haskell than you, or knows something, or is just willing to hang out with you and pair program over Google Hangouts or Skype, or using Visual Studio Live Coding or something like that, that's a good place to hang out. There's a thing on GitHub for like registering like when you're available and whatnot. I do highly recommend it. It's been very good for me. Like the first session we sat down and I was going, even before I did the first session, we sat down and built all the, I built all the backpack-based unpacked container stuff, which was 15 to 45% faster than unpacked containers. In another session, we built the perhaps monad, which is on, there's a perhaps package now. So I built that with Bive Cigar, and we managed to get that built and backported to like GHC 7.2 or something awful. And then the next session was me sitting down with Ariakanam and then doing the beginnings of what this commutative package is. And then at that point in time, I said, well, I've kind of regretted the fact that the last that the last 12 hours or so worth of that content had been eaten by just being lost into like a pair programming void. So maybe what I should do is stream this stuff, because whenever I mentioned that I was doing the pair programming stuff on the Haskell IRC channel, folks asked about streaming. So here we go. I'm giving it a shot. We've got the fancy microphone set up. I've got a bunch of fancy lights and a green screen thing coming, which will help a little bit with the amount of screen real estate my picture takes down there in the corner, which will let me run a second like text editing window or hold a more permanent browser over here on the side without eating up too much real estate. So that's basically where I'm at right now. Right now I'm streaming off of my Mac into a Windows machine, and the Windows machine is doing the recording, but the software I'm using is not so great for that. It's great while it's running, and when it's not running, it's it's awful. It crashes too much. Other questions? Do I think linear types have a future? I think linear types in Haskell are really awkward. There's a linear types extension that's been done, but it's really not linear types. And so you can only supply the linear typing guarantees in the absence of exceptions. And when you're working in Haskell, you have async exceptions that can be thrown at you at any time. And so you can't really rely on the linear type guarantees. And so I don't know how to fix that. And so at least I think the latest version of the linear types paper or write-up or something like that said, hey, look, this is only sound if you don't throw exceptions at me. And yeah, I'm going to give OBS a try next. I first tried using the Elgato software for this, but I found it a little too primitive. I poked at OBS very briefly, and I kind of liked the features in Game Show just a little bit more. Are linear types something like what Rust does with just borrowing stuff? I would think of, in some sense, yes. They at least cover a very similar use case. I've heard a lot of talk about linear types and potential benefits. Do you think it's potential to add linear types and the optimization of linear types? So one of my major concerns around linear types is that a lot of the optimizations that we perform in GHC today are not sound once you introduce linear types into the mix. So if you really wanted to have linear types that are all about those operational resources and stuff, lambda lifting and lambda lowering and stuff like that affect the amount of uses of a variable you have. And so if you start trying to plumb this all the way through core well, it gets really messy. To be fair, we were sitting in a movie theater before the movie started. So let's see, how's our poll turned out over here, by the way? So MCMC is popular, doing a general intermediate session, and then doing a lens tutorial, and getting into this SPMD and SIMD stuff. So this is giving me at least a general sense of what to do. Maybe not in the next session, perhaps, but over the next few. Great. Puff and Fresh. What I'll do is I can try and turn on the hosting thing on my channel, so it'll just rehost you, and that way folks who come here while this is idle will get your stream. Distributed and parallel computing in Haskell. So the distributed computing story there so far has been Cloud Haskell, which I'm not super keen on, but it's the closest thing that we have to the Erlang story. In some ways, it has a harder problem than like Erlang does, which is that Erlang can get away with the fact that under the hood they only have like 4 different things, lists and pairs and like some sort of associative containers, and atoms and stuff. And so figuring out how to deal with error recovery by just serializing dumb, completely untyped data around works pretty well for them. Whereas when we move into Haskell and start doing it, the things that we want to marshal are more interesting and actually are much harder to deal with. And then how do you deal with recovery when you actually have types involved? How do you deal with hot code swapping in those scenarios, etc.? Those things become a bit messier. And so I would say in some ways our story is worse than the Erlang story. And yeah, Marlowe's book is a great starting point for almost anything around like within a computer parallelism. Read Stephen Marlowe's book. It's the book that takes Haskell from being a cute toy to being a power tool. You can upcast the data to your data type, and it might fail if you're in Java. And yeah, you can define a way to serialize out and then back in, and then you can just kind of hope that your serialization format is sound, or dump it to something that's got a little bit more information about the types involved, like using like protocol buffers or something like that. Yeah, there's lots of good intermediate resources for Haskell, but it's not all in one place. How does backpack actually work? I've heard it is kind of like ML modules and seen it used in unpacked containers, but I've yet to understand what it actually does or what it biases, or how it biases the performance improvements it does. Sure, Gani. So what Backpack does is when you first compile your code to and it happens to have abstract signatures in it, it doesn't emit any code. All it does is do the type checking process to say, if there existed a module that had the signature here, would the rest of this code be well typed? And then it sets aside that code in some form that it can turn around and later on compile it with particular instantiations of those module signatures. And then when you actually have a module that implements those signatures and you go to use a mix-in clause or something, what it will do is it will recompile all the code linked against that module with basically the names changed. And at that point in time, it can do things like unpack through names that were previously opaque. And yes, it's a sort of second-class module system because you're making Cabal do all the work of linking all your modules together. But that's the general idea, is that you write code that is sound as long as the module has the type. Do I use session types when I do distributed programming? I'll say this. Everybody who I know who worked on session types to try and get their PhD all didn't finish a PhD because they couldn't get anything published. So it seems like session types are a great way to flunk out of a PhD program. I think they're a neat idea in many ways. Like if you look at the design of pipes where it got split, that actually came out of a conversation between me and Gabriel Gonzalez about if you were to take the the kinds of channels that they had in Singularity, which were like session type light, where the individual channels had a some sort of like state machine with transitions that could be taken by each individual actor. If you took that apart, you wind up with this particular functor, which eventually turned around and became the sort of bidirectional thing that's behind pipes. You're new to Haskell and trying to figure out if you should use Cabal or Stack. What do I prefer and why? So Stack sits atop Cabal. The thing that Stack does is it provides you with sort of an easy way to encapsulate shipping multiple versions of GHC. I actually don't know the intermediate forms that are used by Backpack Disable. So anyway, so the main thing that Stack is giving you is you install Stack, and it's a very, very small thing. And if you want to build a project that wants to use a particular version of GHC, it will go pull it down from the internet. That works really well for private development. It's not so great for a classroom environment, perhaps, where you want to have those GHC things already installed for you. Stack has a pretty good onboarding experience in that regard. If you're just going to be using a single version of GHC, I'm actually starting to like the Cabal new build process a little bit more than the Stack build process. And part of the reason is because Stack currently doesn't support Backpack, so I can't use Stack for some of the projects that I'm doing. And so it's just been slowly filtering out of my workflow. I do understand if you're in a commercial environment and you're trying to ship an application, that working with Stack tends to work a bit better because you're working with these sort of frozen environments. You can make sure that everyone in your dev team is working with a consistent environment. You're not worried about, well, we can only build for deployment on Bob's machine, or we have to freeze against a particular set of exact dependencies. Cabal new build also has a bunch of stuff for saying what the frozen set of packages were as well. How do I reason about distributed systems I develop? What tools and math theory do I use? So I've given a couple of talks on something called propagators. And so propagators are a form of commutative or convergent replicated data type, or a very big generalization of it. And there should be 2 talks available from me online. One is the Lambda Jam talk that I gave on propagators, which is fairly introductory. And so I'll paste that into chat. So this is a kind of brief introduction to commutative, idempotent monoids and what you might care about those things. And then there's a Boston Haskell talk, which was a much deeper dive on the topic, which actually came first, but that one is far more rambly. So both of those talks, I believe, are linked below the chat here, or at least one of them is. And as for distributed programming, I'm kind of a fan of that style of thinking. There's a guy, Chris Michaeljohn, has a project he called LASP, which is about building a Lisp-like thing for working with these CRDTs and trying to compose them. My stuff is trying to do that in a slightly more mathematical way. And then in the sort of in-process form of that, the par-monad stuff by Lindsay Cooper also fits into the whole propagator story. So I was working on that before I had the whole cancer scare thing, and then I kind of stopped working on it because I was very distracted by other things. As for what I use for my own personal build environment stuff, we use Nix and Buck to build everything at work. So I'm slowly becoming acquainted with Nix. I'm not yet willing to use Nix as my day-to-day development environment because I find that working with Nix kind of blinds me to the concerns that every day-to-day Haskell users have. Buck is like Google has their in-house build tool, and there's 2 clones of it. There's Buck and Basil, I think. There's 2 different clones of it out there. Buck is one of those. And we use Buck sitting atop Nix to get our build environments running for all of the stuff that we have working at Digital Asset. They're integrated reasonably well. It's not perfect. There's some things with some sharing that's not perfect between them. I think Bazel might work a little bit better for us for that, but it'd be a reasonably large conversion effort, so we haven't done it yet. Yeah, it's very similar to the configuration that Twig is using, Arian. Do you think it makes sense proving the complexity of algorithm implemented in the size of resources used? It's very difficult to reason about complexity of algorithms in like a formal way in code. There's some work in Agda for doing it. There are things like dual light affine logic and stuff like that where you can actually build a type system where the type system says you can only write programs that converge in polynomial time here, but then the type starts picking up these symbols that are the degree of the polynomial time, and then the writing it in the natural style doesn't work. Frustrated that GHC is not as fast as I've become used to. In many ways, so it is an incremental compiler. It's just it's getting slow. So there's been some work in the last revision or two to try and speed up GHC. I'm not the best person to speak to that. All right. But yeah, see, when I switched into Haskell, I was coming from C++ in the era before Clang, and so Haskell seemed super speedy to me. In some ways, I haven't had RSI problems. I think part of it is the fact that I don't use Emacs, so I don't get into that Emacs pinky pose that causes so much pain. And I also don't type properly, so my hands are moving around the keyboard a lot. So I had a bit of a like carpal tunnel style pain at one point, but that resolved itself reasonably quickly. So I haven't had the suffering. Somebody asked a question on Discord. Let me see if I can see the Discord chat because it gets hidden by. How do I recommend working with records? I mean, record heavy code with lots of overlapping field names. So the style that I tend to use for records is to build a bunch of has-foo classes and such. It's not a perfect style, but I find it better than almost every one of the extensible record stories. So there's a talk by George Wilson. Let me link to it here. And this was based, what happened was I gave a sort of rant to George. And I'll paste it here. Next level MTL. That talk gives pretty much the approach that I use for working with. Oh crap! I dumped it in the Twitch chat. Sorry, Dexter. Here, let me paste it into. I can't paste it into that because it's across different windows. So I'll just leave there, and you can try and grab it out of the stream somehow. Sorry. Oh, good. Adam C. has managed to reply in Twitch or in Discord. And yeah, I've been very lucky in terms of RSI, given that I type all day, every day, and I destroy keyboards. Has-foo is the approach. Make fields is not the approach that I like to use. I like to. I don't like to work with just arbitrary things that happen to have the same field name. I do like to have some kind of logic about having a bunch of related fields together. And so then I build a class for has some thing, which might have a few fields in it, and then work from there. So it's what make classy does, not make fields. But yeah, I use make classy very heavily. Last +1. How are we doing over here? Anything? Okay, so we've run about 4 hours this time. Do I think laziness brings more good than bad?
Or would it be better to have a strict Haskell by default? I think a strict Haskell by default isn't Haskell. I think it is every other language on the planet. Given that every other language on the planet exists, I think losing Haskell would be a far bigger loss than anything gained. I have every other language to think non-lazy thoughts, and Haskell is the only one I can think thoughts about laziness in. And saying that you can do strictness and then do laziness as a bolt-on, everyone who says that you can do this, I think they lack the courage of their conviction, because I don't see enough lazy code in any of those languages to actually live up to that promise. So they're suffering a sort of catastrophic existence failure. What are my thoughts on higher order FRP? Do I think it's the future, or do I think there are better approaches on the horizon? I think FRP is... I think it's great for toy problems. I have not seen FRP scale to the kind of problems that I want to work in. And that's been my concern there is, like, if I try and use FRP for building, I don't know, if I were to try and build a AAA game title out of FRP, I think that it would get bogged down in trying to manage the minutia of all of the preserved state. And so I know how to deal with, billions of things doing stuff, but I don't know how to deal with it all in FRP. I can deal with 10,000. And maybe that's like the solution is to work in a coarser grain with FRP and whatnot, but do I plan to enter into AI with Haskell? So I have a little bit of code lying around for playing around with neural networks in Haskell, like for taking the output of like a GAN or something like that from TensorFlow, and then trying to feed it off to the GPU in order to play with like some graphic stuff. But I don't have anything in a publicly consumable form at the moment. And yeah, FRP does seem like a good way to fail out of a PhD. All right, questions actually seem to be slowly winding down. Any others? Well, thank you, Tenab. I've had a lot of fun. All right, I think this is probably where we'll call it then. And as for a next stream, I was originally planning on being down in New York this week, but it looks like I'm going to be local, so maybe I can do a stream in the afternoon during the week. Otherwise, I'll probably do something on the weekend. Oh, commutative eval. How would you have motivated the specific transformation in eval? Commutative means it's legal, but there's a choice. Yeah, so Ariakonem, why am I trying to do the applicative on the outside? So in the applicative do paper, there's a sort of cost function that describes one model under which we can talk about applicative being cheaper than monadic binds. And that's true for a very simple cost model where each of the operations takes one step and the applicative things could be done in parallel. But if you can view that as doing sums over the monad and doing max over the applicative operations. And that's like working in a tropical semi-ring. But you can also play games and move over to the other extreme of like doing addition and products, where you're working in more of a natural number style cost model. And it also is correct there. And then there's a space of number models between those two extremes, like that are based on softmaxes and whatnot, that gradually converge from addition into multiplication. And they pop up when doing like Viterbi models or something like that. I haven't used them in forever. So there's a whole space of cost functions. And we're correct at the extremes, and the whole system is convex. So we're correct at all of the things in the middle, to use this sort of very naive model. And another way to talk about it is to say something like the expected value of the min of two random variables. Let's see if I can do this, not instead of trying to type it into the chat where no one can see. if I can come up with the... So I want the expected value of the min of x and y, where x and y are two random variables with any distribution. Should be... Is it less than or equal to the min of the expected value of x and the expected value of y? There's a... I have this invariant one way or the other. So if you, even if you just say that the cost function that we're going to apply for each of the members of our applicative and do have some kind of distribution, then the unit evaluation function is correct, even if you replace it with each of the individual operations having a completely independent random variable. So there are a pretty wide class of monads and applicatives under which you should favor doing the applicative operation over the monad operation thing is legal. Least change to do applicative. Did I leave that lying in between monadic? I don't remember using that phrase. Sorry, I'm not following. Oh, is it the least change? We don't actually try and quantify the amount of change in the code at all. All we have is a very... the cost function that we have is based on... the initial sketch that I gave of it was to say... you could view this as a form of like CYK style parsing problem. There's a chart parsing problem that says that this is a dynamic programming problem in one hand, and you can view it in another way as a building a little parser for a context-free grammar. That's how I motivate. So we motivated the transformation in the applicative do paper under those kind of terms, and then. So the algorithm that I described there gives an O(n) cubed cost analysis that computes an optimal into that cost function solution. And here what we're doing is adding commutativity to the mix, but then trying to get the free monad to do it for us so that it exposes things such that when the applicative do transformation is done, you should get something that is optimal even though it's come out of a composition. At least that's the idea. Apparently that join thing screws everything up. So you're going to have to still use the applicative combinators by hand or put these horrible returns in your code. All right. Well, I think I'm going to pull the plug pretty much here. Thank you guys very so much. And what I'll do is I'll probably schedule another session for next Sunday, and it should show up as video in my videos section here. And I've been recording a master recording pretty much since the stream started. So we should have I should have the ability to dump this to YouTube after I do whatever surgery I need on it. So it should be available here for whatever the 2 weeks or so is. And yeah, sorry, Brian, you joined late. So, and Leslie, you're in at the end of hour 4. So, why do I not do so on Periscope? I don't know what Periscope is. What is Periscope? I don't know what Periscope is. Oh, I don't use Periscope because I didn't know about Periscope, and I'm using Twitch because I already had a Twitch account. And I already have a bunch of stuff streamed out to YouTube and stuff, so it seems easier for me to go with what I know at this point. So I might do some homework on Periscope, but I'm not anticipating it greatly changing my life. And Buff and Fresh, so you go start your stream, and what I'll do is I'll switch over to clicking host on it or something like that. I'll coordinate with you on IRC. So if Puff and Fresh, if you start your stream up now, what I can do is I can probably do, I don't know how to do a raid or something like that. All right. We're raiding you. So you better start your stream now. All right, I'm ending mine. And then I'll switch it over to hosting him.